see your first question here highlighted?
Yeah.
Okay. I don't know. It didn't really make. I couldn't really get anything from this, but we're just going to look at each of these on its own. So the x minus 1 up here, that means it's right 1 unit. Okay, so if it's sort of inside parentheses, which is what that is, it's inside, it's left or right because of that.
Oh, okay.
The negative out in front, that is a flip over, and then you have to say which axis, flip over the x axis. And then the plus 5 here is up 5 units. So that should take care of that.
Okay.
The x-intercept is where it crosses the x-axis. The x-axis is the equation y equals 0. So you set y equal to 0. 0 equals negative 2 x minus 1 plus 5, and then you solve for x. So we can do that here. We're going to subtract 5 from both sides. So minus 5 equals negative 2 to the x minus 1. We can get rid of the negatives. 5 equals 2 to the x minus 1 power. The only way to get a variable out of the exponent is to use ln. So we can take the natural log of both sides, and then that exponent comes out in front. So that x minus 1 comes out in front, natural log of 2, natural log of 5. So x minus 1 equals natural log of 5 over natural log of 2. That's just dividing natural log 2 to the other side, and then you can add 1 to it. So x equals 1 plus natural log of 5 over natural log of 2. Also, if you had used Desmos, you would have seen something. It would look something like that, and you might have been able to get that value from
Okay.
Desmos. That's the by hand way of doing this.
Yeah.
All right, so 4. Okay, 4. I'm just going to snip in part B for now because the instructor tried to fill in a lot of. This is 4B, and it says to evaluate. There's a base 10 here, which is not written, and we wrote that whenever you have so let's say you have log base b of x. Well, b to the log base b of x equals x. So an example of this would be like 4 to the log base 4 of 10. This equals 10. 3 to the log base 3 of q equals q. So this part up here, 10 log base 10, it just undoes it, meaning it cancels it out. So the answer here is just x squared minus 2x plus 1.
Okay.
And there's really not much more to say on that one.
Got it.
So let's see here. We can expand the next one. So this one is more complicated than any of the ones that I remember working with you on. You have to expand this. The first view of this is that really it's the log of something on top over something on the bottom. And this is always log on top minus log on bottom. Okay, so this becomes log 3x squared y to the 5th minus log square root of z. Is that okay up until now?
Yeah.
Okay, so now this one on the left, it's log a times b times c, and that becomes log a plus log b plus log c. So it literally becomes log 3 plus log x squared plus log y to the 5th minus log. Now instead of this, square root of z is really z to the 1/2 power.
Okay.
So the exponents can come out in front. So this 2 can come out in front, this 5 come out in front, this 1/2 can come out in front. So it's log base 3 plus 2 log base x plus 5 log base y, or log of y minus 1/2 log of z. And that is fully expanded.
Okay, I got it.
I got it. All right. Okay. Yeah, I like what you wrote in number 7. He or she may not
Yeah.
have liked reading it because it calls them out on something that they
It's
did.
like, if it's not on the review, I don't know how I'm supposed to know it. Like,
Yeah,
what's doing?
this is a synthesis problem. I actually have this question in one of my SAT ACT practice books, and that I if you ever want to they go down that road and work on some of those problems with me. It's a synthesis thing. Like the instructor's expecting you to do see some other things here. Let's start with this one. Log base a, 18 square root of 18 is 18 to the 1/2 power. What can you do with this exponent?
Put it 1/2
Yeah,
log.
1/2 front. Log base a of 18. Now, you are supposed to know that 18 breaks apart into 2 times 9, 3 times 3. Okay, so this is 18 can become 2 times 3 squared. Okay, so that's 1/2 log a, and then we can separate this into 2 plus 1/2 log a 3 squared. That's using a property from the previous problem. This 2 can come out in front, so it's 2 times 1/2. That becomes 1, so plus log base a of 3. And then they give you the values. They say that this is x, this is y, so you can write it as 1/2 x plus y.
Okay.
C is probably the one we should have done first because it would have been clearer what to do. But we'll go to B next. So B says, part B is log base A 9 over 10. So it's log base A 9 minus log base A 10. So the 9 here, in terms of like the values you have, it can be written as log base A of 3 squared. And 10 is 4 times 5. Well, actually, they don't use 4, they use 2, so it's really 2 squared. I can see that 2 squared, 2 times log base A of 3 minus, so this becomes log base A of 2 squared plus log base A of 5. And then this negative goes to both of these, and that's kind of a common mistake that you'll see is where you don't distribute the negative to both.
Oh yeah.
Oops, I just did it from being careless here. So let me get that deleted. Okay, minus log base A of 5. This 2 can come out in front. 2 log base A of 2 minus log base A of 5. So now we have some values here. Log base A of 3 is y, log base A of 2 is x, and log base A of 5 is z. So this is 2y minus 2x minus z.
Okay.
This is I would not, even if you saw this is still a pretty tough question. You're not
Yeah.
alone in needing to
I
see
have
it
no
again.
idea.
Yeah. All right, so we're up to question 8.
Oh, wait, can we do C?
Oh yeah. Yeah, we should do C. Let me cut this and then we'll start again. So C was the one we should have started with. It's the most straightforward. Log base A, log base 3 of 20. Oh, actually, I take that back. See how all the givens are in terms of A.
Yeah.
If we go log, actually, this one, your instructor must have meant that this was A. That's the only way I can think of this, how to do this. So 2 and 10, 2 and 5. So this is 2 squared times 5. Maybe not. Anyway, let me just do it this way, and then you can confirm with him. There's maybe another way to do this. So this is a product, so it becomes a sum. Log base A of 2 squared plus log base A of 5. You can bring the 2 out in front. 2 log base A of 2 plus log base A of 5. And then this log base A of 2 is x, and this is z. So it's 2x plus z. Now, if it truly is log base 3 of 20, I'm not sure what your instructor had in mind there, so you may want to confirm
Yeah, I
with
can
him or
ask.
her on that. All right, the next question here. All right, so the right 4 is correct. The order of this this is really up to.
Oh,
That's from that, but the order is inappropriate. It's flipped and it's horizontally over the y, because the y goes vertical. So when you flip over it, it's a horizontal reflection.
okay.
Yeah. So this, and then this really should come at the end, but the rest of it
Okay.
looks okay. Why did you lose points there? Did you graph this?
Yeah, I graphed it on Desmos.
Okay. The range is 2 to positive 2 to infinity.
Oh,
It comes from that. The y-intercept, that's when x is 0. Okay, so let's go through the y-intercept. So y-intercept is when x equals 0, and it's y equals log base 2 negative 0 minus 4 plus 2. So 0 minus 4 becomes negative 4, but then you negate it, so it becomes log base 2 of 4. Log base 2 of 4 is 2 squared, and there's a property that says that becomes a 2 plus a 2, which is 4. I don't know about that. That looks good to me. And then the x-intercept is when y equals 0. This one may not have one, because when you said 0 equal to log base 2 minus x minus 4 plus 2. Okay, so you move this over and you get negative 2 equals log base 2 of the rest of this. To undo the log base 2, you use base of 2. So 2 to the negative 2 equals 2 to the log base 2 negative x minus 4. So on the right, it just becomes negative x minus 4. 2 to the minus 2 power is 1 over 2 squared, or 1/4. So then you negate it, you do that, and then this negative can come down here. So you get negative 1/4 equals x minus 4. You can add 4 to both sides. That's negative 1 over 4 plus 16 over 4, which is 15 over 4. So that's your x-intercept, 15 over 4 comma 0.
okay.
Yeah, I think it's that. 9's good, 10 not so good. All right, 10.
Yeah.
All right. You invest $10,000 at 1% compounded daily. So the for me, like, a big thing that's missing here is the formula. So the formula is the amount that you have is the amount that you start with, 1 plus the rate over the number of compounding periods times the number of compounding periods times time. So in your problem, P is 10,000. Okay, your R is 0.01. N is comes from this. Daily is 365, and then T is 20. Does this look familiar now?
Yeah.
Okay. All right, so this is definitely a calculator problem. It's 10,000, 1 plus 0.01 over 365 times 20. It should be worth, I mean, you're not that far off, I don't think.
Yeah. I used an online calculator to.
Yeah, if you don't get them, I get this $12,213.99.
See, it was right.
Show your work.
I didn't show my work because
No.
it did not work the show.
Yeah. All right. So now you got to figure out how long until it's worth 15,000. So you got 15,000 over here on the left equals 10,000. 1 plus 0.01 365 to the power of 365 times t. All right, and it does say show your work. I don't know, like I kind of just want to put in 48 years and see if you get, if you just didn't show your work.
Yeah, I guessed on that one. So
Yeah, no, you're way off.
but I feel like it was pretty accurate.
Yeah, I mean, it's actually, it's closer to that than you would think. I mean, but to do this correctly, you have to divide both sides by 10,000. So that gives you 1.5 equals 1 plus 0.01 over 365 to the 365 t power. So the only way to get a variable out of the exponent is to use natural log. So you take the natural log of both sides, and I'm just going to bring it out in front all in one step. 1 plus 0.01 over 365. And then to get t by itself, you divide by all this. So t is equal to natural log 1.5 over 365 natural log 1 plus 0.01 over 365. If you put this in your calculator, you have to add an extra parenthesis around the bottom part. You could also use Desmos and graph this.
Okay.
So I get 40.5 years, and that's what I meant by you weren't that far off.
Not bad.
All right, I'm going to move on to 11, unless there's some follow-up to that.
Nope, I'm good.
Okay, the value of a certain card depreciates 11% each year. So if it went up in value, so your growth is equal to 1 plus r. Your decay is always equal to 1 minus r. So depreciates is another decay thing. So your equation here is like however much your car was worth when you bought it, 1 minus 0.11 to the value of t.
Okay.
And this is just a standard. This is PAT. PERT is the other one you see, but PAT is where you have the decay.
Mm-hmm.
So this one just says to put. This one just says put t for 6 in for t.
Okay, I'll put it in my calculator.
Yeah, so this is 0.89 to the power of 6. And I'm not sure what that is, but it's gone down, kind of significantly, actually. It's actually kind of a reasonable thing that it's gone down in half. $22,364.16.
Okay.
Okay, so part B now is to estimate when it will become $5,000. So it's worth $5,000. It started out at $45,000 and 0.89 to the power of t. So this is part B. So to do this, you're going to get rid of this 45,000. You're going to divide both sides by 45,000. So this ends up being 1/9 over here equals 0.89 to the power of t. The only way to get a variable out of the exponent is to use natural log. So we got natural log 1/9 equals natural log 0.89 to the power of t. This t comes in front. So you have natural log 1/9 equals t natural log of 0.89. Divide both sides by 0.8 natural log of 0.89. So you have natural log 1/9 over natural log of 0.89. We'll get some values for that. Eighteen 18.9 years. That's probably unreasonable. It actually probably goes there faster than that.
Okay.
Okay, so you said that the last page is...
Yeah, I sent it to you in the email.
Okay,
It's just
there
chapter
it is.
7 test, and it's the 4th page.
Okay, solve each equation, then use your calculator. Okay. So it actually happens more often than you would think with these tests, where you just don't see the last part. Okay, so to solve this, you want to isolate this e thing. So you have to get rid of the 4 and the 3. So you're going to add 4 to both sides. That gives you 12, and then you're going to divide by 3. So that gives you e to the x plus 1 equals 4. The only way to get a variable out of exponent is use ln or log. Because it's e, you would use ln. ln of e to the x plus 1 equals ln of 4. So this ln undoes the e, so it becomes just x plus 1. X plus 1 equals natural log of 4. You subtract 1 from both sides, so x equals natural log of 4 minus 1. It does say to round to the nearest thousandth, so you definitely want to put that into your calculator and make sure you see how to get this 0.386 for that.
Okay.
Let me see. The rest are logs. Sometimes they mix these together where you don't get. Okay, so this one, to get to the x, you have to undo the log ln. You have to undo ln, and you do that with e. So e to the ln of 2x plus 5 equals e to the 3. So this is 2x plus 5 equals e cubed. And then you have to undo this plus 5 and times 2. So you're going to subtract 5 from both sides. You get e cubed minus 5. Then you're going to divide by 2. So that's e cubed minus 5 all divided by 2. Your calculator has the e button on there. I'm going to get this. I got exponential of 3 minus 5 over 2.
I got 17.586.
I've got slightly different number. Make sure you get your parentheses around this.
Oh, I did it over the bottom.
7.543.
Okay.
Okay, part C is using, you have to know to solve, you have to know to compress or combine these logs first. So this is like log of A plus log of B. This becomes log of A times B. So this becomes log base 3 x minus 2 times x plus 2 equals 2.
Okay.
So you can combine these, you can FOIL this in here, or you can wait to do it later. I'm going to do it now. It's difference of squares, so the outer and the inner become are the same except they're opposite in sign. So it becomes x squared minus 4 equals 2. To undo the 3, you have to use a base of 3. So it's 3 to the log base 3 of x squared minus 4 equals 3 to the power of 2. This undoes each other. 3 to the log base 3 undoes it. It's x squared minus 4 equals 9. Add 4 to both sides. X squared equals 13. X equals plus or minus the square root of 13. So you have to check these because sometimes they're extraneous. And in this case they are, because it's not because it's negative. It's because when you put the value back in, when you check negative square root of 13, you're going log base 3 negative square root of 13 minus 2 plus other stuff. This in here is negative and this is undefined. So this one's not, does not work. But positive square root of 13 is okay.
Okay.
All right. Part D here, you have to take an extra step to combine before combining them. Put the 2 here first. So that's natural log x squared minus natural log 3 equals 2. Then you use a property natural log of A minus natural log of B becomes natural log A over B. So this is natural log x squared over 3 equals 2. To undo ln, you use e. So it's e to the natural log x squared over 3 equals e to the power of 2. X squared over 3 equals e squared. Multiply by 3 to clear the divide by 3. X squared equals 3e squared. Then you take a square root. So x equals plus or minus square root of 3e squared. You do have one extraneous here, the negative square root of 3e squared. When you check it, 2 times the natural log of negative square root of 3e squared. This is undefined. So the only one that works is positive square root 3e squared.
Got it.
Do we need to do the extra credit?
Sure, I might get extra points.
Okay. I see that you sent something else also. Is that something to work on?
It's just a few homework questions, but they're not due till later in the week. So
okay. All right. Well, let's get to the first extra credit here. One of the things, like when your instructor says, oh, it says, he keeps saying show work. I was going to say you could just we could just put these in the calculator Desmos, but when show work, you can't do that. All right, so these are substitution problems, and you wouldn't know that until you had seen this one time. So the substitution is almost always the middle thing, middle term. But it's not the whole middle term, it's just the one with the variable. Then you have to square it. This is where you might not know that this equals e to the 2x. It should almost always equals whatever there. But when you have an exponent to exponent, you multiply them, and that's why it's 2x.
okay.
So it's u squared minus 9u plus 14 equals 0. So to factor this, you get u minus 7, u minus 2 equals 0. So u equals 7 and u equals 2, but you're not solving for u, you're solving for x. So you have to back substitute this up here. So it's really e to the x equals 7 and e to the x equals 2. Do you recall how to solve those two equations? So to undo e, use ln. So ln of e to the x equals ln 7, x equals ln 7. Over here, it's the same thing. Natural log of e to the x equals natural log of 2. So x equals natural log of 2. You can punch that into your calculator.
Where's natural log?
It should be under e in your calculator. Are you finding it?
No, I can't find it.
Let me search here.
Catalog search.
You have a TI 83 or 84?
84.
Okay. So I'm just pulling up an image. Let me see if I can find it. They don't zoom in on all the keys. It's ln. It's next to the 4, to the left of the 4. Do you see that?
Oh yeah. Oh, it's just a normal button.
Yep.
Okay.
Okay, great. Now let's go to the next one here. Okay, so to combine these, you're going to use the property natural log of a plus natural log of b equals natural log of a times b. So this becomes natural log x minus 4 times x minus 3 equals 2. To undo ln, you use e. So e to the natural log x minus 4, x minus 3 equals e squared. And so the left side, it's x minus 4, x minus 3 equals e squared. So this, I would probably graph this. I'd probably put this into y1 and this into y2. What it'll look like is some sort of a quadratic that goes through 3 and 4. So it'll do something like this, and then e squared is about 8. So it'll hit it in those two places there.
Yeah, that's what it looks like. Okay. Got it.
Okay, what should we move on to next?
I sent a few homework problems. There's like 5 of them. I think we can get through them.
Okay, which can you give me the numbers?
Yeah, 1 second. Okay, for page 503 and 504, it's 16 and 26.
Okay.
And then page 512, 22 and 28.
Okay. So 16 and okay, so we got. All right, 16. It says suppose that x and y vary inversely. Is that what you're looking at?
Yeah.
Okay, so if they vary inversely, that means that y equals k over x. This is by definition. Just have to know that. They they give you x, they tell you x is 20 and y is -4. This means that you can solve for k. So k is equal to x times y, or you can just put the numbers in. -4 equals k over 20. K is -4 times 20, which is -80. So you rewrite the equation. You always rewrite it. Y equals -80 over x. And then so now you have to put x equals 10 in. It says that it says to graph the function, which I guess you can put in your calculator, -80 over x. So it looks like something like this. But I think really the emphasis is on getting the value out, which is -8. Ready for 26?
Yeah.
Okay. Okay, so z varies directly with x. Okay, let me snip this one in. This one's got more words to it. So directly means you multiply, inversely means you divide. Let me get this snipped in. So z varies directly with x and inversely with y. So that's this. K is always on top.
Okay. And then you just plug the numbers in.
You do for this. You get K. I'm sorry. They give you z. Z is 15. 15 equals K. X is 6. Y is 2. So you solve for K. You end up getting that K equals 5. So you rewrite z equals 5x over y.
Okay.
But I think there's more to it. I think they want you to actually they want you to find z now when x equals 4 and y equals 9. So it's 5 times 4 over 9. So it's 20 over 9.
Oh, okay. Got it.
Okay, so now we're on to the next assignment, which you said is question 22 and 28.
Yeah.
Okay. All right, so question 2, it says to sketch the graph. Sketch the graph of each function, identify the domain and range. So there's a lot to doing this if you have to do it by hand. I would assume your instructor will ask you to do it, will show work on the exam. The first thing you look for are these vertical asymptotes. So this one has one at -6 because x plus 6 equals 0 at x equals -6. So that's a 1, 2, 3, 4, 5, 6. So the line over here. This one is a horizontal asymptote at y equals -1. So really roughly, the graph looks something like this.
Okay.
Okay. The domain is everywhere except for the vertical asymptote or totes. There might be more than one. So in this case, it's -infinity to -6, union -6 to infinity. It's just that place where it's not included. The range is everything but the vertical asymptotes.
Okay.
So the range is everything but minus one. So it's minus infinity, minus one, union minus one to infinity.
Got it.
And again, you can graph this. That would also help, I suppose. And then you said 28.
Yes.
Okay. Okay. All right. So this question, we're kind of, I mean, there's really a lot that builds into these questions, and that's the challenge here. So they're telling you the parent function is y equals 2 over x. And they're telling you that there's asymptotes here and here.
And then we have to like make the equation.
Yes.
Okay.
So the vertical asymptotes go on the bottom.
So it's
Okay. So
X
you see, yeah,
4.
it's x minus 4, because that's what, if you, one way of looking at it is like if you move it over, but it's whatever makes the bottom 0.
Mhm.
This number just comes down here, so it's minus 8.
Okay.
That's, I mean, that's it. There's nothing more to do.
Yeah, it's not so bad. All right. Well, that's all you got to do for today.
Excellent. Well, thanks again for scheduling, and I'll send you the notes and screen recording out later today.
Okay.
Thanks so much. Have a good, bye now.